let's do a problem involving the case where we have even powers of sine and even powers of cosine. This is a fairly complicated example, so I'm only going to do one. Or at least I'm only going to take up one board's worth. So we're going to find the integral of sine to the fourth 3 theta times cosine squared 3 theta d theta. So if we look over here, we see that if we have even powers, we need to use those power reduction formulas. And you know, I think that's another way to say it. I've been saying like half angle identity, but it's the same. They're really related. If you look at those identities, they're all kind of related. So anyway, we got this. It's disgusting. So the nice part is when they're both even, you can pick whichever one you want to do. I mean, because you're gonna have to do both, so you don't have to figure out which one's gonna be what. So what we're gonna do is we're gonna separate this into the squared pieces and then go. All right. Less talking, more doing. So what I got to do is I got to say, all right, I'm gonna want this in terms of sine squared. So that's going to be sine squared 3 theta squared, and that's going to be cosine squared 3 theta d theta. So this wasn't set to a power. If this was like to the 8th power or something, I'd have to do cosine squared 3 theta to the 4th. But now that I have these in terms of, for this canonical piece here, I can use that. So what I'm going to do is, I'm going to say, all right, that's sine squared is 1 minus cosine. Now what you do is you double the angle here. You say 6 theta over 2 squared. Then 1 plus cosine 6 theta over 2 d theta. It's the same idea here. We're using the 1 plus, you double the angle. Now what I notice is I could rewrite that as 1/8 6 theta squared plus cosine 6 theta d theta. And I could do that because I'm dividing by 2. When I square that, that's like dividing by 4. And then when I divide by another 2, that's dividing by 8. So I'm going to pull that 1/8 out to make my life a little easier. The next thing I want to do is I want to square this piece. I want to say, all right, I'm just going to square this thing out. So that I can use the FOIL method here. Pull the 1/8 all the way out front. That gets me 1 minus 2 cosine 6 theta. So that's, 1 times 1 is here, 1 times this is negative cosine 6 theta, this times that is another negative cosine 6 theta, and then I have to multiply these things again, so I get cosine squared 6 theta. So 1 plus cosine 6 theta d theta. Now, the next thing I want to do here is I want to multiply these things together. So I get 1/8. So I'm going to get 1 plus, so we'll go ahead and shorthand this and write that, because this is going to be a positive cosine 6 theta, but that's going to subtract 1 from it, so you ultimately get a negative here. So there's 1, there's going to be that, and that. So this becomes negative 2 cosine squared 6 theta, but then you add another cosine squared 6 theta. And then finally you get that. So yuck, right? We're still kind of stuck here. What's nice to know is that this piece and that piece have direct integrals. We can solve those. But this one's a cosine squared, so what we have to do is we actually have to reapply this formula. So what I'm going to do is I'm going to split this up into separate integrals because it'll be easier to solve that way. I'm going to split this up into 1/8, 1 minus cosine 6 theta d theta, minus 1/8 cosine squared 6 theta d theta, plus 1/8 cosine cubed 6 theta d theta. And the reason I want to do that is because this we're going to solve with the odd power formula. This we're going to solve with the power reduction. And this we can directly integrate. So as a result, I'm going to start and switch to kind of some multicolored pieces here. I'm going to start writing this one in red. I'm going to leave this one in blue. And I'm going to do this one in purple to try to emphasize that these are separate pieces. So the 1/8, 1 minus cosine 6 theta d theta. Well, notice that that piece directly is just theta over 8 minus theta over 48 sine of 6 theta. So you might ask yourself, how did I get that? Well, if you take the derivative with respect to theta, that's like, you know, it'd be like if it was x over 8. You take the derivative, you just have 1/8 left over. You take the derivative of here, the chain rule gets you cosine of 6 theta times a 6, which will cancel with the or reduce with the 48 to get you 1/8. So hopefully that's straightforward enough to you. So that piece is solved. What's left over is this piece. And then this piece. Now what I'd like to do is I'd like to do the purple one now and not worry about the blue one for a moment, because the blue one is going to take a little more work. Let's focus on this purple here. Now we need to use that same power reduction formula we did before, or the same, yeah, whatever it is. So I can separate that into cosine 6 theta and cosine squared 6 theta d theta. I can use the Pythagorean identity to set this up, 1 minus sine squared 6 theta d theta. So then I can use a u substitution. I can say u is sine of 6 theta, so du is 6 cosine 6 theta d theta. Again, don't forget your chain rule. So then that we would have to divide by 6 here. So that becomes 1 over 48. 1 minus u squared du, which then becomes u over 48 minus u cubed over 144. And we're gonna put the plus c on this one, but again, u is sine of 6 theta, so that becomes sine of 6 theta over 48 minus sine cubed of 6 theta 144 plus c. So now we've solved this piece and we've solved this piece, so we need to still solve the blue piece. Now the blue piece is going to require another angle reduction formula. So I have this squared, so I need to use this yet again. So I have minus 1/8, 1 plus cosine 12 theta, or 2 d theta. So then I can pull out that 2 on the bottom. So that's minus 1/16 plus cosine 12 theta d theta. So the antiderivative of this is just theta. The antiderivative of that is 1/12 sine of 12 theta. Which is disgusting, right? I mean, we can simplify that to negative 1/16 theta plus 16 times 12, I think it's 192. Is that right? Minus 1 over 192 sine 12 theta. So now I have this piece, and that piece. So let's put it all together. Our final answer is 1/8 theta minus 1 48. That shouldn't have been theta over 48. That should have been 1 over 48. I sure hope you noticed my mistake. My bad. 48 sine 6 theta minus 1/16 theta minus 192 sine of 12 theta plus 1/48 sine 6 theta minus 1 over 144 sine cubed 6 theta plus c. Now what's kind of neat of this is you're going to have some cancellation. Notice that those 1 over 48s are going to go away. So those 1 over 48 6 thetas are going to disappear. And then these will actually simplify to a positive 1/16. So I get 1/16 theta minus 1 over 192 sine of 12 theta minus 1 over 144 of sine cubed 6 theta plus c. So this is a fairly complicated problem. What you see is that even powers are difficult or challenging to contend with, and they can get even more challenging if the powers go up even higher. So this is something that's going to require practice, and hopefully this is a fairly good overview of how we not only split it up, but sort of the ways that kind of are helpful to split this integral, because the techniques you're going to use to solve each of these pieces may be different.